So, hello everyone. My name is Constantinos Asargiotakis. I'm an Angular developer, and we're going to speak tonight about the latest updates that version 17 presented. So, let's start with the presentation. Okay. So, first of all, we see that Angular 17 has a new logo. I think it's pretty nice, related to the old one. And starting from the latest updates, as we can see, we may have up to 90% faster runtime. That is, the main reason is the new control flows. And the really nice feature here is that there's a script to do it automatically. We may also see faster build time, and even on runtime, the times are improved by far. Another important thing is that we now have Angular.dev. It's the new web for Angular, where the documentation is amazing, and there's also a nice playground to work with your code, and you don't have to download anything. You can just play and do it automatically. We now have Node.js version that is 18 that is required for the latest version. And another nice thing is that there's a support for TypeScript 5.2 that has a lot of nice things. More improved signals, we could say, and effects. Another main issue that we had in the past, it was the CSS things that were left on the DOM, and now it's improved. We have better server-side rendering and static-side generation. We have new lifecycle hooks. We have a new build and runtime for the new projects, and we also have the deferrable views. Deferrable views are going to be presented from finished product. So starting from efficient CSS removal. So that was an issue that we could see previously on the older versions, where moving from one component to another may lead to having styles on your DOM that is not removed properly, and that could affect your performance of the application. So as we can see here, this is Angular 17. On the left screenshot, we use a class, a CSS class, from to-do component that is called red class. And then we move into another component, so the to-do component is destroyed. We use another class that is called green class, and as we see, there is no red class remain on the DOM. As I told before, the main thing is that having too many unused CSS classes on your DOM would have a degraded performance. You could have unnecessary bloating styles that would affect components that they do not use directly, those styles. And of course, memory leaks. Stable server-side rendering and static-side generation. So starting from server-side rendering, where server-side rendering is a process where we build our templates with an initial state of the values that we use, and we save it into our server. Where static-side generation is when you completely create and build your application, you store it on your server, and this is going to be static. So why we need to use SSR and SSG? The main issue is the improved performance, of course, because you don't have to wait for your client in order to execute and bootstrap the application. Another a nice one is that we have improved core web vitals, like the first contentful paint. We have the largest contentful paint and time to first byte. And also, we have better search engine optimization, which leads to having our application be on the first results on Google. So, in order to achieve SSR and SSG in the past, we had to use Angular Universal and Scali in order to activate it. They were third-party libraries, but now with Angular 17, it's supported out of the box. When you create a new application, you are going to be asked if you would like to enable it, as we can see on the screenshot below, or if you upgrade from an older version, then you could easily add it by doing ng-add at Angular SSR. We also have new lifecycle hooks. So we have after render. After render is a callback that is going to be called each time that the rendering is done, where after next render is actually the same as before, but it's going to be called only one time that the rendering is finished. We could see here some screenshots where we see that our component on the left side, it starts the life cycle, it's constructed, then it goes engine changes on init, blah, blah, blah. And when everything is over, we see the after render. And it's the same hook on each change detection. In order to completely understand the after render, after next render, there's a really nice game to play online on the link that I have here, and you could also see the code on GitHub. And the main point here is to move your using your key arrows to move the red point on the blue, so you can, let's say, win. When we construct, we see here a part of code from the previous repository that on the constructor, on the after render, we draw each time the point and the point to touch. So this is the red one and the blue one points. And on after next render, we initialize our board. Another improvement is that we now use Vite and ESBuild for the Angular 17 projects. Why we do that? Because on Angular 16, Vite and ESBuild was used as an experiment, and we found out that many developers reported even up to 17 build time improvement. And that goes far beyond when we use SSR and SSG, that we could see even up to 87% improvement on build time and on refresh loops on ng-serve. This is a screen here that shows a comparison between the legacy builder that we used in the past and the new builder. So we see that with the new ESBuild and Vite, the time to build and serve an application is way decreased than before. One of the most important features is that we now in Angular 17 support TypeScript 5.2. TypeScript 5.2 has a lot of nice things like explicit resource management, where this is a common pattern in other software development, where we specifically use some keywords in order to release resources and make our application even faster. For example, before, in order to release a resource like a file, on the left side, we could see that we should load the path, and then we should load the file. We should add some logic like try catch in order to find when we don't need anymore the file to release it so we get back our resources. But now on TypeScript 5.2, there's a keyword that's called using, and this is going to do everything automatically. I mean, it's going to, when we finish our job, it's going to release the resources by itself. Decorator metadata. So in TypeScript 5.2, we now can use the values of the properties that we bind with the decorators. As we can see here, we have a decorator that is called serialize on a class of a person. Person has some properties like first name, last name, age, and it could have way more. But we want to have, let's say, just these two properties. So when we are going to log the information of that person, we would like to show in a JSON format the name, the first name, the last name, and the age. With the decorator metadata, we could see that now in serialize function, we could store the values of the properties that are binded with the decorators, and on the function JSONify, we could parse them and show as we want. Named and anonymous tuple elements. So that was a bit of annoying issue in the past, where if you would like to declare a type, all none or all should have labels. As we see on the first line, we don't have no labels at all, but on the third line, if we see that only the first property has a label, but the second one doesn't have. So that would throw an error of tuple members must all have names or all not have names. So this issue is now resolved. Another nice one is the methods usage of union arrays. So in the past, when you had an array that could contain strings or number types, you couldn't filter the array because TypeScript would say that string is not a number. Okay, this is obvious. So with the latest version, we see that TypeScript actually transform its entry on the row to be of type string or number. So that solves the issue. We also have now the ability to copy arrays when we want to do some functions on it, like reverse, like sorting, like splice, or even updating a specific row of our array. With the latest version, JavaScript is going to first create a deep copy of our array, and then is going to apply all the methods that I described before. So, for example, my array is going to be, in the past, we had to create a new array and do all the functionality there in order to not break the data on the original array. In order to enable that in your TypeScript, you should include esnext.array in your tsconfig.json. We now have the ability with the type-only import paths to include interfaces with a specific extension, where that could be .ts, .mts, .cts, and .tsx, where in the past we were only using interfaces from TS files. Another feature on TypeScript is now that it's going to automatically complete the commas when we forget it. We also have now inline variable refactoring, where that means that if we select on the left side to replace the sum functionality, TypeScript is going to remove it and delete it from all the usages that exist in that file. So you don't have to go manually and delete the sum. As we can see on the right side, the multiplication function is it's done automatically. Now let's move into more Angular parts. Finally, signals and effects. So signals were introduced in Angular 16, and now they became stable. And that means that we could use all that functionality in order to improve the performance of our application combined with change detection. So let's start by what is a signal. So a signal is a wraparound the value that could notify the consumer of that signal that something changed. Signals could contain any value from simple primitive types to data structures, whatever. And why do we need signals? Because of performance. On the left side, we could see that in order to detect change detection, we should use the zone.js that was done by Angular, where it should, when she was notified that something changed, the change detection would run through the whole component tree and update anything that is required. But now, with signals, when something has changed, the change detection is going to run specific on the consumer component that gets the value of that signal. We see a nice example here where on the left side, we see that an event happens, and then Angular runs through the whole component tree to specify if a component needs to do some updates on the view, where on the right side, now that we use the signals, we have a producer and we have two consumers, and only these two components are going to be updated. And that means that we gain a lot of time, and the performance, of course, the performance is way improved. So we have different signals. We have two types, and we have also a new one. First, we start with the writable signals. So writable signals are mutable, where you could set, reset, update, you could get the values. And we also have computed signals, where they get the values from the writable signals. We use the computed signals in order to use the value from a writable signal and do some kind of computation that we need. Starting from writable signals, we see on the code that we should use the keyword signal and provide an initial value. Now the variable count gets the value from the signal when it has emitted a new value. We could also set and update the value of the signal very easily or where we want it. Another thing that writable signals have are that they provide equality functions. What does that mean? That in order to prevent having multiple emissions with the same value, we could provide the function that it would assert if the current value of the signal is the same as the one that we're going to set. In that case, the signal value is not going to be emitted, so we don't have any change detection. Now, the computed signals. The computed signals, as I told you before, they derive their values from the writable signals. We see that we have a signal count that has an initial value 0, and then we use the computed keyword in order to consume the value of count. A nice thing on the computed signals is that they cast their value, and when the value is the same as before, they don't emit, they don't do the calculation again. So again, we save our resources, and the performance is going high. And now we have the effects. The effects are asynchronous functions that are going to be triggered based on the values from the signals. They can read a value from a signal without tracking their dependencies. So, for example, here we have two signals, but we only want to track the value of signal of only the first value of the first signal of current user. We have also the effect of we have also the signal of current date, which actually emits every single second, and it logs the time and date, where the current user is going to be emitted when a user is going to log in on our application. And we see on the logs below that even though that the current date is emitted every second, the second effect doesn't log every second because we use the untracked keyword to specify that we don't need to track the current data, the current date, but we only want to track the current user. In order to save our resources, destroying effects is going to be automatically when the enclosing context is destroyed. For example, we use an effect on a component, and that is going to be, the effect is going to be destroyed when the component is destroyed as well. But we might want to destroy the effect before the ng destroy, for example. We could achieve this by using the onCleanup function callback, where it's going to destroy the effect on demand. As we can see here, we have a current user signal, we have a timer, and when the onCleanup is going to be called, then we're going to clear the timer. And we now have a new built-in control flow. I think this is one of the major updates of Angular 17 because it could change totally the way that we write our templates. So there were a lot of developers that complaining about the template syntax because it was a little bit odd for them that they couldn't understand. So after some research, Angular team created the new syntax that, except from it's better because it's more close to the JavaScript. So a new developer that will go into the Angular framework, it's easier for him to understand what's going on the template just by reading it, just by reading the lines. We also have better type checking that we didn't have before. We have significant performance improvements that we're going to discuss it next. So previously we had star ngIf that now became @if. We had ngSwitch that now is @switch, and ng4 became @4. Starting with ngIf, as we see on the left side, in order to do a simple ngIf else, we had to apply the ngIf condition on the top, and in order to achieve the else block, we had to use a template, where now the else block is supported out of the box from Angular. We see that we just need to provide the condition that we want. The isApple is a Boolean, and if this is false, it's gonna go into the else block. We have a nice improvement here on the switch, even though that the syntax it's not totally different as before. But the most important part with the switch is that now we have the type check on each case. So, for example, if I will write with the new syntax, the first case where actually the fruit it's a string property. So in my first case, if I write 1, that is a number, then we're going to get a warning on our template, and that means that we may fall outside of this case because we mistyped something, or I don't know. And finally, with NG4, a nice improvement here is that the track, previously it was called track by, is now important. You have to declare the track, and it also has the empty block. So previously, in order to achieve, in order to check if the fruits array was empty, again you should use an ngIf condition, and then on your template, then use a template to show a message that you have an empty list of fruits. But now with a new template, with a new syntax, we see that we just declare as an empty block, and this is going to be executed automatically. Yes, okay. This is what we discussed before. Because of the track is now mandatory, we may face up to 90% faster runtime. Because as we know, if we have a lot of entries into our arrays, this is going to decrease the performance of the application. In order to automatically update the template syntax, you just have to run nggenerate at Angular core control flow, and this is going to be, I think it's a really nice feature because it's going to do all the dirty job automatically, and it will update all the control flow that we discussed before. Now, the final part is the deferrable views. This is a part that you're going to discuss with more details with Fanny's. We see here that we have now the ability to defer big chunks of code and use them only when we need them. And of course, again, that means improved performance. So that was all for me. I hope you enjoyed the presentation.